This is section 1.2, Summary Statistics, and in this video I'm going to talk about outliers and how to calculate quartiles and percentiles. First, let me talk about outliers. Let's suppose that we have a sample, so this is a sample. In which we can locate the elements in the samples are over here, but for some reason that sometimes happen, we have an element that is far away from the others. So this element that is far away from the others is called an outlier. And is far away from the rest of the data. Let me write it explicitly. Far away from the rest of the data. So that could be different things. There might be certain reasons. One of them is just an error, that the measurement that you took at that point, it was wrong, or it could actually happen that um, the sample that you took was particularly on one side and the outlier is probably telling you that the sample is not representative. So you have to always look. So what should you do in those cases? Well, first of all, consider that it's an error. So it could be an error. Second, always analyze why we have an outlier. Always analyze why we have the outlier. And finally, do the analysis with and without the outlier. Later on, as you progress in the analysis that you're doing, you can make some conclusions about the outlier, but just keep it in there. Do not delete it from your data. Just it could be telling you something important and you never know. Okay, sample median. So this is another measurement of the center of the data. Another measure of the center of the data. And as the name indicates, it's the point in the middle position. So how do we find the median? So that's the procedure. So first of all, order n data points from smallest to largest. So sort the data. Okay, and I'm going to suppose that we have 1, 2, 3, 4, 5 data points in this case, and in the second case I'm going to assume that we have 4 data points, and they are ordered. Now in the first case we have n equal to 5, and in the second case we have n equal to 4. So in the first case it's easier to find out what's the middle one, because we have 2 at one side, 2 at the other side, and so we know that This is the position in the middle. In the second case, however, so we have 2 in this side and 2 in this side, and there is nothing in the middle. So which one do we choose? So, and that would be the general case. So when we have an odd case, so that would be odd, n is odd, and when n is even. So in the case when n is odd, so the position in the middle is easier. So if we have 5 plus 1 divided by 2 equal to 3. So and that's going to give us the position in the middle. So we have n plus 1 divided by 2 in this case. But in the even case, so what do? We do exactly the same thing, n plus 1 divided by 2, but that's going to give us a non-integer number. In this case was 3. In this case, if we have 4 plus 1 divided by 2 is 5 divided by 2 is 2.5. So in this case, this is an integer, and in this case is not an integer. So it's a real number with decimal part. When we don't have an integer position, like in this case we have 2.5, that is something in between, so n plus 1 over 2 is not an integer, we can have we can select these two positions, the one before and the one after. So we can have the I or the j position, where I is the lowest and j is the highest position, and we can take the average of those two positions. In this case, in this example, so the lowest position is position 2 and the highest position is position 3. So we take the average of the two, average of positions I and j. So let's say we have two samples. In the first case, we have 1, 2, 3, 4, 5 elements. So this is n equal to 5. And in the second case, we have 1, 2, 3, 4, 5, 6, n equal to 6. So n equal to 5, so we apply the formula, which is n plus 1 divided by 2, which is 5 plus 1 divided by 2 is equal to 3. So the position is 3. So this is 1, 2, third position. So the median is equal to 68.31. In the second case, we have n equal to 6. We apply the formula. So we have n plus 1 divided by 2, which is equal to 6 plus 1 divided by 2. So this is 7 divided by 2 is equal to 3.5. So we have the two options. We have 3 and 4. So we take the average of positions 3 and 4. So this is 1, 2, 3, and 4. So the median is equal to 4 plus 8 divided by 2, which is equal to 6. And we can apply the mean in both cases. In this case, if we apply the mean of x is equal to the sum of xi divided by 5, we are going to obtain it. This is equal to 68.7, and in this case, the mean of y, which is y bar, is equal to the sum of yi divided by 6, and this is going to be equal to 10. You can verify that if you do it by hand. Okay, another interesting case of subdividing the data is to compute the quartiles. So when we are talking about quartiles, we are talking about dividing the data in 4 different regions. So that's a quartile. So let's say that we have our set of data and we order. So we are going to have, this is our data. And so we are going to divide by 2. So that's going to be the median. And then each part is going to be divided by 2. Well, that's supposed to be right in the middle. So we are going to call this position Q1. This is Q2. And this is Q3, quartile 1, quartile 2, and quartile 3. So Q2 corresponds to the median, and Q1 will represent the limit in which we'll have 20% of the data. So 20% of the data is in this region, 20% of the data is in this region, 20% of the data is in this region, and 20% of the data is in this region. So we are divided by 4. So that's why it's called quartile. Okay, so Q2 is the median. So Q2 is equal to the median. And so how we compute it? So we have n plus 1 divided by 2, and if we have an integer, we are good, but if we don't have an integer, not an integer, so then we have to take the low and the high position, low and high position, and compute the average. That's the option that is presented in the book and is accepted as the middle point. In the case of Q1, so in the case of Q1, we have all n plus 1 multiplied by 1/4, and then we proceed the same way. If it's an integer, we are good. We just took the value of that position. If it's not an integer, then choose the middle point, middle value. And Q3 will correspond to 3/4, so n plus 1 of which are the data, number of points, multiplied by 3/4 or 0.75. And the same thing, if we have an integer, we are good. If we are not an integer, we can take the middle value. Okay, so that's very well accepted, although they can have some variation in the case when we don't have an integer value. We can go not just divided by 4, but we can just divide by any number. So in that case, we are going to have a percentile. So percentile will define a fraction of the total sample, and that fraction could be, or a percentage of the total fraction. So how do we do? So basically we proceed as before. So we order the sample from the smallest to largest. We convert the percentile to a fraction and find the position on the array. Okay, let's consider the following example in which we have this sample 1, 3, 7, 10, 5. We have 1, 2, 3, 4, 5. So n is equal to 5 in this case, and we want to find the 30% percentile. So the percentile is the 30%. So in this case, our sample is sort from lower to highest. So we proceed to convert the percentile to a fraction. So that's going to be 30 divided by 100. And now we multiply by n plus 1. So we multiply by 5 plus 1, which is equal to 6 multiplied by 30 and divided by 100. That's going to be equal to 1.8. So meaning that we don't have an integer value, so this is going to be in between positions 1 and 3. So positions 1 and 3, sorry, 1 and 2, positions 1 and 2, which corresponds to the values 1 and 3. So the standard way is to take the average. So the average will be 1 plus 3 divided by 2. So this is 4 divided by 2 is equal to 2. So the 30% percentile is equal to 2. Now I have mentioned that when we have a non-integer value, we take the average of the two positions. That's one option, and that's the option that is present in the book. However, is not the only possibility. Okay. If you use any software like Python, like R or SSPS, you will find that there are different ways of computing the percentiles. And in general, the function is going to be called Quantile. So Quantile is the command that you are going to use to compute the percentiles, including the quartiles. Okay, so what we have said so far is that when we have a non-integer position, so when we have a non-integer, oh, we have a happy O. We have a non-integer, then we are end up with two positions, the I and the J position, the low and the high position. And I have said so far that you take the middle point. So the mean point is the average. But you can actually take the lower position, so take just the I, take the higher position, or take the nearest position, or a linear combination in between the two. Like in this case, so the lower will be 1, and the higher it will be 3. 2 will be the midpoint, and the linear it will be 1 plus the linear combination in between 1 and 3. So how do you do in the different software? Well, there is the function called Quantile. In the case of Python, is Quantile. You have to input the array that you want. In this case is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 positions. So very convenient. I wrote it very convenient so we could see. And so if we use the interpolation of midpoint, what are we going to have if we are looking for the 75%? So the 75% is right here. So the 75%, the midpoint is going to be x 75 midpoint is going to be equal to 7.5. So the answer will be 7.5. The lower is going to be 7, Finally, the linear, x75 linear, and the linear is defined in the following way. So we have two positions. We have the low and the high position, and we have the distance between the two. So we start with the low position, so which corresponds to the value of 7. So we have 7 plus, then we have the difference in between the two, so it will be 8 minus 7, and multiply by the percentile that we are looking, multiply by 0.75. So in this case, it will be 0.75 of 1 plus 7. That's going to be 7.75. And as a matter of interest, the default in most of the software is the linear one. Okay, it's not the midpoint, the one that we have in the book. So be aware when we play and we need to calculate the percentiles and the quartiles, and you use the software, that usually the approximation that is going to give you is the linear approximation.